Yes. Okay, great. Pam, thank you so much for that warm welcome. As Pam said, I've been on the job just for a couple of weeks, and this is my first talk to an audience of this size, so take it easy on me, all right? Seriously, it's a delight to be here. The work that ESTO does and the ESTO community does has been really fascinating and delightful to follow over the years, and so I'm thrilled to be here with you all today. Because I'm new in the job, and also because the Science Mission Director at NASA recently released a new strategy document called Science 2020 to 2024, a vision for science excellence. I thought what I would do in this first out-of-the-gate presentation is to try to pull the thread all the way from NASA strategy to the work that you and the ESTO program are doing, and show you how it all fits together, and then hopefully we'll have time for a few questions. So with that, could we go to the next chart, please? So starting all the way up at the top, this is the NASA vision and mission statement, and then that flows down into the Science Mission Directorate vision. And to me, this is a pretty inspirational set of statements, really linking to benefiting humanity in a variety of ways. But you just look at the words on this chart, right? Discovery, pioneer, transform, unlock opportunities, and innovation. So this is really what we're all about, and the Science Mission Directorate then further took, in this recent document, these statements from the NASA level and the Science Mission Directorate vision, and codified the Science Mission Directorate approach to how are we going to achieve these really aspirational goals. So if you go to the next chart. So this is really where we start to draw the link between the Science Mission Directorate and NASA Earth Science. We're one of several divisions within the directorate. The Science Mission Directorate mission is it's got three components. The first is to discover the secrets of the universe. Okay, so that's huge. Search for life elsewhere. And then protect and improve life on Earth. And although the Earth Science division arguably contributes to questions of the secrets of the universe, really what Earth Science focuses on is that last piece, to protect and improve life on Earth. And that's really what I've highlighted here. And the major way that I think about how do we do that? Well, first we've got to make some observations and measure, and then use those measurements to advance our understanding, and then convert that understanding into delivering societal benefits. Because our ability to thrive on Earth, on our home planet, and of all the planets out there, this one is my favorite. Our ability to thrive here is undeniably tied to our scientific understanding and our predictive capability of our very dynamic environment and the phenomena underlying it. So this is sort of the macro picture, and of course, as everyone on the phone knows, it's very easy to say this in a few high-level bullets, but if you go to the next chart, we of course understand just how complex a problem that is. And this cartoon is even vastly oversimplified, but we can talk about land processes, ocean processes, and the water cycle, atmospheric processes, cryosphere, atmospheric composition, the carbon cycle, the biosphere. All of this, individually we may study these various components, but it's really how those all interplay that is the challenge, and that's really where earth science is going. It is taking the understanding that we've developed over decades of observation and research for each of these systems and really starting to understand how do they play together. And of course, this is the Earth systems view, but as we all know, there are strong connections also between the natural systems and the human systems and the economic systems. So that's really where we start to turn the understanding into impact. So this is sort of the broad view of the Earth system, Earth science team at NASA. And if we hit the next chart, so now I'm going to drill down one more level. So if our objective in Earth science, in order to achieve that mission, if our objective is to advance the knowledge of the Earth as a system, and to do so on the timescale that are needed to plan and understand not just where we are today, but where we're going, to improve life on the planet today, but also in the future, then we break that down into, all right, well, so what do we have to do to advance that knowledge? Well, there are really four major elements as I see it. One is we need to develop the technologies that we need to make observations. In some cases, observations we haven't yet been able to make. In other cases, observations that we have made before, but we would like to do so more affordably so that we can free up some headroom to make new observations. So there's an enabling technology piece right up front. Then, of course, the next thing we do in neuroscience is we make the observations. Make the observations we need to see these Earth systems that we're talking about. That's really probably what Earth science is best known for. And then the next step is to take those observations, convert them into understanding. And this is really where modeling comes in, and the interconnections between these systems. And then the last step is to take that understanding and bridge out to decision makers so they can apply it in the day-to-day decisions that they have to make. And this is federal, state, local, tribal. It's within the economics, within every economic sector. They have decisions that they have to make based on knowledge of the environment. So when I break down the problem of how do we advance the ball here, it breaks down into these four sort of major steps. And then if we hit the next chart, it then shouldn't come as a surprise to anyone that this is reflected in the current organization of the Earth Science Division. So we have different elements, different programs. I'm using the word program sort of loosely there, but different teams focus on the four different elements to solving this problem. So we have this robust program that runs from technology on the left, which is developing and demonstrating future technologies, including, of course, small sats, CubeSats, and so forth. Then bringing those to flight, and that may be initially through demonstration missions, but then also through decadal missions and so forth. Using those observations in research and analysis, that's again the answering scientific questions, going after things that mechanisms we don't understand today, and then codifying that understanding in models that result in predictive capability. And then our applied sciences team really makes the bridges out to the users of the information to try to show them how they can use the information and deliver it in a way that is most impactful for them. So on this chart, the way I see it, we're running the full spectrum from innovation on the left to impact on the right. And of course, that's oversimplifying it a bit. Of course, in technology is not the only place innovation happens, but of course it's a critical enabler. So let's see. Let's go on to the next chart, please. I mentioned right up front that that just at the end of May, the Science Mission Directorate released this Vision for Science Excellence, and it's a really great document. I actually, I don't know if this community of folks have seen it yet, so I sent a copy of it over to the organizing team. I do encourage you to take a look through it. One of the very interesting elements is this document codifies NASA's science leadership priorities. So these are cross-cutting priorities in exploration and scientific discovery, innovation, interconnectivity and partnerships, and inspiration. And again, that innovation piece, that's really where, well, I hope you all see yourselves in every one of these priorities. But focusing in on, where is the center of gravity for the ESTO activities, it is right there in the innovation priority. So, I hope that this gives you some sense of where the very important work that the ESTO community is doing fits into the larger Earth Science and Science Mission Directorate and ultimately NASA priorities. Because you're leading the way. So I think the next chart is my get off the stage chart. So this is our current fleet, and it's a pretty impressive fleet. A lot of partnership activity on here, a lot of, fair number of smaller and CubeSat kinds of missions with more to come. And those are listed over on the right. If you just hit enter one more time, maybe it'll come up. I don't know. I try to get fancy with the animation. There it is. Yeah. The question really is, what's next? And I look to this community of folks to really be teeing up what is possible for the future NASA Earth fleet. And with that, I will stop talking at you, and I don't know how we're doing time-wise, and we may have time for some question and answer.
We're doing great on time. Thanks so much for that, Karen. Right. So our plan is to have a Q&A time. We've got about 15 minutes, I think. So if you would have a question and you'd like to ask Karen or Pam, feel free to type that into the chat box. And Elizabeth, I think, will be reading our questions for us. So we'll take just a moment if you guys want to formulate any kind of a question to either Karen or Pam.
Yeah, so I'll just jump right in and ask Karen the first question while people are thinking, and that is, given we have this fairly new decadal survey, what do you think is our biggest challenge in implementing that?
Well, so the decadal survey was is a pretty ambitious plan that also calls on us to deliver on the program of record from the prior decadal. So what that means is we've got a fairly encumbered Earth science budget for the next several years. So one challenge will be starting up the new decadal mission within the resources we have. And of course, that all got more complicated just in the last, where are we now? I guess we're going on 4 or 5 months with COVID. Because we are, well, as everyone around the country has had to, we'll just use the phrase adjust their plans. In some cases dramatically, in other cases less so. But as we've had to, and will continue to have to make adjustments in our programs, that will complicate these decisions. So I think really today the biggest set of challenges are figuring out how to manage our resources to get everything, to get new things started, to deliver on our current commitments, and also manage this significant challenge we have. But that's really another way that I think ESTO and the community that we're talking to today can help. Because another challenge associated with the decadal is, in my view, the decadal came out a couple of years ago now, and it was significant process to get there. And so the technology that people could see from there, the folks that wrote the decadal and did that analysis, that has already changed. I think the environment that we are operating in is changing at a rate that is stunning. And I think there are a few factors there. One is, of course, the rate of technological change, miniaturization, what we can do with digital electronics today, just as a couple of examples. But also, the demand for actionable information is changing, is increasing at a rate that we've not seen before, and that has in part to do with, I think with the effects of climate change and increasing severe weather and it's the combined increase in severe events, not just weather, but other environmental events as well, and the increasing impact of those. That's creating an incredible demand. When you have enabling technology and increased demand, then you have people figuring out there's money to be made. That's the trigger for the commercial new entrants. And figuring out how to engage with the private sector in a way that's productive for them and for us is another new challenge. I think it's a really welcome challenge for me. I think it will open some doors, but will also create some challenges. So when I mentioned innovation, it's not just technological innovation, it's innovation in the ways that we partner, in the business arrangements we're willing to try. It's all the way across the how we implement. And then, of course, with commercial interest, there comes pressure for spectrum and these other kinds of resource questions that are not associated with dollars. So we've got a very dynamic environment, and it's much more dynamic than I think we even could see 3 years ago. So that means we've got to take the advice and the program that was laid out in the decadal, but move forward and implement it maybe in ways that are even more creative than what the authors envisioned. So I think that was a long answer, but it's a broad set of challenges.
Thank you so much. Since I'm talking, I'll just read the next question. I see two in the chat. So Karen, given your experience with I'm just going to call it ESTO study, what are your thoughts on how NASA and NOAA can work together in terms of demonstrating innovative new missions or technologies over the decade? And that was Chris Bedka from Langley, I believe.
Yeah, I think there's a lot of opportunity there, in part because the decadal called out the importance of collaboration, but also because the ESTO study, and for those who are less familiar with that, it was really that was a cost-benefit analysis that was really trying to look at what are the attributes of a future NOAA architecture that could, at best cost and impact, achieve NOAA's mission. And there were a lot of elements in there. It was really a very, we called it the architectures that competed best in that analysis were hybrid architectures. They had some larger elements, many smaller elements, significant partnership elements, and so forth. So I think if NOAA and NASA can agree on some common priorities and roles toward achieving those, I think we could certainly multiply one another's mission impact. But to do that, we've got to identify what are those things that really do advance both missions, because of course a partnership actually has to benefit both partners. So I think we've got to have some creative conversations there about what are the things we could go after together that would really advance both missions.
Great. And there's one more question from Konstantin Lukashin, also from Langley. Hello, Karen. A question about what's next. What do you think about the approach? For example, a systemic approach for designing a next-generation Earth observing system.
Let me ask this. I'm not sure I understand what the question is about. So, was the question about whether we should do an INSOSA-like study for NASA? Is that the question? Or
Paul, could you unmute Constantine?
Hello, Karen. This is Constantine. Can you hear me?
I can. Hello.
I'm asking question is in a sense of we are trying to do one mission at a time, and we sometimes not overly connected to each other. And as a past EOS, the next generation could benefit from a systemic approach, in my view, to play together. For example, there could be some interconnection with the Landsat next generation, SDG next generation, and one example could be the Europeans series of Sentinels. Basically, they implementing one after another, and in a very organized fashion of sorts. So, what are your thoughts on this?
Yeah, so I really appreciate that question, and I'm afraid I'm not going to give you a satisfying answer yet, only because I'm just a couple weeks on the job and I'm still learning about all the really great analysis that is currently going on within the Earth Science team. For example, we've got dedicated study teams, and of course, many of you on the phone may be participants in those, looking at the options for achieving the decadal designated observables. And those options all include partnership kinds of opportunities, as well as various types of constellations. And what I need to do, and I haven't done it yet, what I need to do is really see what those study teams are coming up with, and then working with our partners, or potential partners, but working with NOAA, with ESTA, with UMETSAT, with JAXA, working with all of our partners, really look at not just what would it take to do one, X, fill in the blank, but exactly as you identified, how could we, taken together, construct a broader architecture, and that element is similar to what we did in the NOAA study. Is really took a look at the broader context of who is doing what and how could we best augment, leverage, and construct something that's bigger than the sum of the parts. But I don't have an implementation answer for you yet because I'm really still learning an awful lot about what the choices are.
Great. Thank you so much, Karen. So we have another question that came in from Charlie Powell from NOAA. Great plenary. Okay, that's not the question. The vision you outlined seems to span a very wide range of TRL. I think he means to say, where do you see the focus for NASA Earth Science? Is there a strong focus on tech development or tech maturation for delivering innovative Earth science discoveries? If both, how do you plan to straddle these potentially competing interests?
The competing interests were the low TRL, and what was the other interest Charlie was asking about?
Where do you see the focus for NASA Earth Science? Is there a strong focus? Yeah. Or tech maturation for delivering innovative Earth science discoveries?
Okay.
Three questions here.
Yeah, so I'm not sure I will.
Low versus high TRL. I'm sorry.
I got it. Low versus high TRL. Okay, so yeah, instead of answering this in terms of TRL, maybe what I'll do is I'll answer it in terms of risk tolerance. So for some observations, we may have less risk tolerance. And so we may construct, we will construct less risky programs. But one of the things, and actually if you do pick up a copy of the Science 2020 to 2024, one of the things that we do talk about is the need to invest not just words, but real resources in low TRL, higher risk missions, demonstration missions, technology development, and so forth. So I really think what we're talking about again here is a hybrid. It's a sort of a balanced portfolio. There's some things for which I really probably can't tolerate a lot of risk, but where I can, and there's benefit to doing so, then I think we ought to be very open to that. And again, ESTO is a place. This front end tech development really is a place where we should be more open to taking on risk. And what comes along with taking on risk is not just saying that you're taking on risk, it's actually understanding that everything doesn't work out and have that be an okay part of the program. I think that's a concept that Pam and certainly George and the whole ESTO community has embraced, I think, over the years. So I don't know, Pam, do you want to augment that thought?
Yeah, I would say, within ESTO, it's really earth science nursery for observations, right? So we have a variety, and our AOs are very broad with the exception of a couple, like we have sustainable land imaging technology that is very focused for the future technology of Landsat to make it more affordable and sustainable. And we also have a new program line within ESTO called Decadal Survey Incubation, which is focused on two targeted observables, planetary boundary layer, and surface topography and vegetation. So those are focused in order to get the technology ready for the next decadal. And so I would say compared with the other science divisions, we do have very open solicitations, and we are being a little bit more aggressive with the TRL and accepting a little bit more risk. And our INVEST program, which has been since 2012, so that's the in-space technology validation, has been very fruitful in reducing risks and learning lessons on how you might do the next version of some of the continuity measurements we have right now. And so I'll just leave it at that. I don't know if I answered everything. I will be giving a sort of a closing talk at the end, and so as questions do come along during the next 3 days, I will try to incorporate answers, and it'll be a fluid presentation. I've noticed that Chris Ruff has a question. Are there any changes in emphasis expected with future ESTO AOs in response to COVID? Maybe I'll try and answer that at the end of ESTF. And there is another question. How are we doing on time, Paul? Do we have till 1:40?
Yes, we're fine on time. We've got till 1:40.
8 minutes left. Okay, so the next question, and I don't see, this is from Dan Cecile. I don't know where he's from. Hi, Karen. I am glad you mentioned the importance of the program of record. Do you have thoughts on sustaining the program of record, especially considering that many sensors/satellites are already in their extended ops phases without direct replacements planned? Good question.
Yeah, that's a question that we're working hard on within the Earth Science team. We did recently extend several platforms. But yeah, that's a significant question, and in some cases there is the possibility to sort of hand off to other sensors out there, whether they might be NOAA sensors or European. That's not going to be the case, that's not going to be true in all cases. So we're looking at that question. We're looking at that question now, and it's in the context of completing the commitments from the old decadal, and still trying to make room to start the new. So we've got a lot of balancing to do. We're just, or at least I am just starting to think about how to do that. And I see that the question above that from I can't tell. Is has to do with increasing the funding. And of course, I can't in a forum like this really talk about the deliberations on funding, but we do have active conversations going on about what is the right size to budget to achieve the expectations, and commensurate, frankly, with the impact that Earth Science has. By the way, Earth Science has about 10% of the NASA budget, and in my humble opinion, that is the most impactful 10%, but don't tell anybody else I said that, because I think that could get me in trouble around here.
Being recorded.
No, we're not fine. Yes, there's always a worthy conversation about what could we do with more, but that said, we do have a significant budget, and we do have a budget that we have a fair amount of flexibility with. So I think the first challenge to us should be to show that we've done the most or are doing the most we can with the resources we have. And so that's really what I'm going to focus on in the near term, even as these conversations about, well, what could we do with more are ongoing.
Yeah, and Upendra, I do see your question, and I just want to add to that answer. As the years go out, we get very close to 5%, if we're not already yet there. And a comment I used to say to Mike Freilich was, yeah, we don't have a huge amount of money, but, in any given year, we have about 130 active projects, and it's what you do with the money that you have and how impactful is that. And I think, we've been doing very well with over 830 projects since 1998. It's the only technology program within NASA headquarters that has lasted that long. So we must be doing something right.
Yeah, I will second that.
There's another question from Jason Heang, so he's from JPL. Do you see a technology direction transition in support of research science to actionable science in support of benefiting society and saving lives?
Yeah, so I think the way I will answer this one is, I think what you're asking about is do we treat research science different from applied science in terms of technology? And I will say, in my view, it is a continuum. There isn't research science over here and applied science over there. And in fact, one of the things that I'll be working with the team on is trying to make that more seamless. And then likewise, sometimes when you're closer to that applied end of the spectrum, you learn things that suggest that there's a research question you haven't answered correctly yet, right? When you find that your applications fail under certain circumstances, for example. So I would like to see much more fluid connection between the ends of the spectrum of science. And I'm not 100% sure I understand the question where you're asking, you see a technology direction transition. So, but I think what we're trying to do is invest in technologies that advance understanding, and that advancement of understanding can happen because we are missing a fundamental science question, or it can happen, or it can happen because we need an observation in a sustained way to continue delivering on the understanding. So I think our technology investments extend across that full spectrum. And by the way, these comments have been probably a bit more flight-centric than they should have been, because there are also technology investments in compute, high-performance compute, and analytics that also are key enablers, again, across the board, from say, curiosity-driven science questions to applied.
Yeah, I would agree. You know, we do within AIST have a new observing strategies strand, if you will, and we're working on a test bed. And I would say that's probably a technology direction that would definitely support new kinds of research science, et cetera. And you know, of course, we have the AITT program that goes from ESTO to RNA. That's one example. And you know, we also have the INVEST program where there's, you know, some valuable science coming out of that as well. So we're at 1:39 right now, and I don't see any other questions. So Karen, I think your talk was great. It was the right amount of time and slides to enable the community to ask you all these great questions and great answers, of course. And so I just wanted to thank you from all of ESTO and the participants for your time. We really appreciate it, and we know you're very, very busy right now. So thank you very much.
Thank you for the kind invitation and the great questions, and I'll look forward to working with this entire community for to together come up with the real answers to them. So thanks again, and I hope I won't be able to stay with you for the whole 3 days, but I hope it's a great conference. Thanks.
Thank you so much.